All right, so today we're going to wrap up our section here on factoring when there is a number in front of the x squared. We'll do a few more of those, and then we'll look into some special cases of this kind of stuff that actually turn out to be pretty easy. So let's go ahead and get started. Okay, so once again, this guy here has a couple possibilities because the multiples of 6, there's 1 and 6. Get this thing to right, that would be good. There's 1 and 6, and then there's 2 and 3. All right, so same thing over here because they're both 6s, right? So this guy will have the same thing. So what we're looking for is a combination that will give us 37x. Now that's pretty big compared to the 6s. So I'm thinking we should probably try the 6 and the 1 in both cases. So let's do that. So we'd have 6x for one of them, and then we'd have x for the other. And plus here means plus and plus here. So these guys are both pluses. All right, and then I think we'll also use the 1 and the 6 for this one as well. So since 37 is pretty big, we need to put a big number here because we're going to multiply it by 6, and we want to get a fairly big number there in the middle. So we're going to try the 6 here and the 1 here. Okay, so then to check that, we just do 1 times x, that's 1x, and then 6 times 6 is plus 36x, and 36 and 1 is 37x. So if you get those guys to match up, you're pretty much golden. So that's our answer. Okay. So for the next one, we don't like negative signs in front of our x squareds or a squareds or whatever it is. It kind of tends to foul things up. And foul was not my first choice of words, but anyway. So the math hack to this one is, like I said, we don't like negatives there. So what we can do is we can factor out, quote unquote, a -1. And when we do that, then all these guys will switch signs. So this will become 6a squared, positive. This will become positive 25a. And this will become positive 25. So we just have to remember to leave that -1 out front. All right, so again, let's see if we can come up with some possibilities here. All right, so for the 25, there's 1 and 25, and there's 5 and 5. I would probably go with the 5 and 5 just because if you use 25, you're probably going to get numbers that are way too big. So I'm going to throw a 5 here and a 5 here. Okay. So then we've got all pluses, so that means we're going to have pluses down here. So then the final thing we need to do is we need to figure out which numbers we should use for the 6. So again, possibilities for this one, there's 1 times 6, and there's 2 times 3. I don't know why when I write at the top of this thing, it doesn't want to write, but it doesn't. Okay, so if we put a 6 in there, 6 times 5 is 30. That's already too big. And we're going to add to it from there. So it's too big. So I'm thinking what we need to do is we need to use the 2 and the 3. All right. Let's give myself a little more room here. All right. So let's go ahead and put it doesn't really matter since they're both 5s. We'll put the 3 here and the 2 here. And then we'll see if that gets us where we need to go. So again, we do 2 times 5, that's going to be 10x. And we do 3 times 5, that's going to be 15x. 10x and 15x is 25x. I know we're using a's, but I started using x's. That's okay. All right, so that works out. So then the only thing we have to remember is we need to put the -1 out front. Just bring him along, and then that's it. But it's a lot easier that way. Like I said, that's a good math hack because you don't want to have to deal with negative signs inside our parentheses because that just tends to mess things up. Okay. Questions? Feeling reasonably assured nobody's going to say anything. Moving on. Just the same problems? Looks like the same. Well, no, I guess it isn't. Oh, okay. So this one's got a smaller number in the middle, plus it's got a negative. So for this one, we might want to try the 2s and 3s instead of the 1s and 6s like we did on the previous problem. So let's go ahead and set up shop. So we're going to have 1 plus and 1 minus, and the overall thing is positive. So I'm thinking our bigger number is probably going to go with the positive. So we'll put 3 here and 2 there. Then let's use 2 and 3 again. Let's put the 2 here and the 3 here. And again, just make sure that your inside-outsides work. So the inside guys, 3 times 3 is going to be 9x. 2 times -2, that's -4x. So 9 minus 4 is 5. So that's our guy. That wasn't too bad. Okay, so this one you can do some factoring as is, but what will normally happen is we'll just run into places where we'll have to factor out stuff later. So if we can factor out a number right now, that would probably be good. So I would say 10 right off the bat, but then we got the 16, so that kind of messes it up. So I'm thinking maybe we can drag out a 4. So let's do that. Let's bring a 4 out front. And then that means divide all these guys by 4. So 16 divided by 4 is 4. B squared. And we've got 60 divided by 4 is going to be plus 15. And then finally we're going to have minus 25. Okay. Oh, I forgot the x here, or the b, or whatever it is. There we go. Okay. So first thought is, since the middle guy is an odd number, we probably don't want to use 2 times 2 to get the 4, because if you multiply anything by 2, it's going to end up even, and if you add 2 things together, they're both even. They're still going to be even. So that's kind of a good hint that maybe we should use 4b and then b. Okay. So again, I'm thinking we probably want to use 5 and 5 as opposed to 25 and 1, because that would give us too big a number in the middle. So we'll go with the 5s. Since the overall thing is positive, I would say let's put the positive that it corresponds with the 4b. So let's make this guy plus and this guy minus. All right. So then we do a quick check. So here I've got minus 5b. And I got these two guys, so I've got 4 times 5, that's going to be 20b. So 20 minus 5 is 15b. And we're trying to match up this guy this time since we factored out. So we're good to go there. The only thing you have to remember, so this is all good, just remember to bring this 4 down with it, and that's all you need. Okay. All right, so that pretty well wraps it up for this. We're going to move on to some special cases. Questions before we move on? check out some special cases. All right, so the special cases, let's talk about that. Let's actually just throw a slide in here, and I'll show you the two formats you're going to see. All right, so there's two types of things you'll see here. We're going to start with the multiplying it out, and then we're going to look at turning it back into things like this. So one thing we've seen a lot is something like so if they had x minus 3 and x plus 3. So this is a special case. And we just want to do this here to establish the pattern. So if we FOIL this guy out, x times x is x squared. X times 3 is going to be plus 3x. And then minus 3 times x is going to be minus 3x. And then finally we have negative 3 and positive 3. That's going to be minus 9. So you're going to see a definite pattern here. So notice that our middle terms here, we had a minus 3x and a plus 3x. That means those guys are just going to cancel out, and I'm just left with these guys. So the moral of the story is this: if you have your number and your variable look the same, except one of them has a negative and one of them has a positive, you will not get a middle term. You will just get an x squared and a number. That's this guy. This is called the difference of two squares. Okay, so anytime you see something that looks like this, what we're talking about here is we're just saying, okay, we're going to take the square root of x squared is just x. The square root of 9 is 3, and since this is negative, you'll have 1 plus and 1 minus. So what we're going to look at here, we're going to look from going from here back to here. So another example might be if I had x squared minus 25. Okay, so your first clue that this is going to happen is there's no middle term, there's no x term. And you look at our two terms, x squared is a perfect square because that's x times x. 25 is a perfect square because that's 5 times 5. So then your basic setup is going to be this. So you take the square root of x squared, we get x. You take the square root of 25, you get 5. In order to multiply two numbers together and get negative 25, one has to be plus, one has to be minus. So this is the pattern that you'll see throughout these things. So that's the one case. Then the second case, I'm just going to go ahead and make another slide here real quick. So the second case is, what if we had x plus 3 squared? So x plus 3 squared is really x plus 3 times x plus 3. So if we do our normal FOIL thing, we do x times x, that's going to be x squared. Then we do x times 3, that's going to be plus 3x. Then here we've got 3 times x, that's another plus 3x. And then finally we've got 3 times 3, which is just plus 9. And when you're squaring these, it doesn't matter if this guy's negative or positive. When you square the number, it'll always be, this last term will always be positive. So that's a good thing to note. All right, so notice then that we have our middle terms. We have two middle terms here, and they're both 3x. So we can add those guys together, and that'll give us 6x. And we just bring everybody else down. Okay, so after you've done a few of these, you kind of notice a pattern. And the pattern is that you square the first guy, we get x squared. Square the second guy, we get 9. Then the way you can get the middle term pretty easy is you say, okay, I can multiply 3 times x and get 3x, and that's going to happen twice. So then I can just double this guy, and I get 6x. So there's my 6x. If I square this guy, I get x squared. If I square this guy, I get positive 9, and that's our guy. Okay, so what we want to look for is let's look at another one here. When we're going from this, oops, hang on. So when we're going from this back to this, here's what you want to look for. So say we had x squared plus 8x plus 16, and we want to factor that guy. Okay, so again, the hack for this one, you are going to get, obviously you have a middle term. So what we can do is we can say, all right, if I take x squared and take the square root, I'm going to get x. And then the next thing you look at, you say, well, if I take the square root of 16, I get 4. And if you take that square root of 4 and double it and get the middle guy, then you've got this going on. Then you've got x plus 4 and x plus 4. And of course, the lazy math guys are never going to write it that way. They're going to write x plus 4 squared. Okay? So that's what you look for. You look for a perfect square here, a perfect square here, and then when you take the square root of the number and double it, you should get this number right here. So again, if you take the square root of 16, you get 4, you double it, you get 8. That's what these guys are. Okay, so another quick example, and let's use a negative this time. So if you had x squared minus 10x plus 25, you say, okay, I take the square root of x squared, I get x. Take the square root of 25, I get 5. Now in this case, since this guy's negative, this goes to our standard rules. If we have a plus here, we need 2 pluses or 2 minuses. And that's dictated by this guy. So if he's minus, these are minus. And again, this would be x minus 5 squared. Okay, so that's where we're heading with all this. All right, so let's check out some examples. So it says, identify the value that would make the trinomial factoring using the perfect square pattern. So this time they want us to come up with this number. So let's see what we were doing on the previous thing here. So we kept saying we are going to take the square root of this guy and double it. So in order to figure out this guy, we would take 8 and divide him by 2, because that's going to happen twice, right? Which gives us 4. Once we get the 4, in order to get back here, we took a square root, so we undo it by squaring this. And that would give us the 16. So that's the pattern we use here. So you take the number in front of the x, divide by 2, and square it. That will tell you the number that has to be on the end in order to get a perfect square like this. Okay, so for this guy, what we do is we say, okay, we've got 24. We divide him by 2, that's going to be 12. And we take 12 squared. 12 times 12 is 144. So that's that guy. And bring the sign along with it, but it doesn't really matter because when you square it, it's still going to be positive. Okay, so like this guy, he's minus 10 divided by 2, so that's a negative 5. But when you take negative 5 and square it, you'll get a plus 25. So that's your guy. Okay. All right, so a little different story here because we got this guy out front. But notice something. We've got 6 and 36. So that means I can drag a 6 out front. Okay? And then this is going to be x squared and then minus 6x. And then we'll figure out our constant. Okay, so for this, we do the same thing. We're going to take the minus 6. We're going to divide him by 2. So it'll be negative 3. Square it, and we're going to get positive 9. Now for the original equation, to get this number back, we're just going to take 6 times 9. So the original one would have been a 54. But it's easier if you could factor some stuff out and figure out what this guy is and then just multiply it back together for the top. Okay, so 28 is pretty much the second verse, same as the first. This one I can factor out a 3. And then we'll have x squared plus 8x. All right, so then to figure out our middle guy, or not our middle guy, but our last guy again, you take our middle guy, divide him by 2. So 8 divided by 2 is 4. And then we're going to square 4, and we'll get 16. So that's plus 16. Okay, so to get the original guy back, all you have to do is take the 16 times the 3, and 16 times 3 is 48. So that's how that works. So if you just have an x squared out front, just go ahead and divide the number in front of the x by 2 and square it, and that'll get you your answer. Now in this case, when we factor out a number, we'd really like to keep this as an x squared because it makes this guy a lot easier to work with. And once we do that, then we can figure out a number here, and then just remember that we multiplied by 6 and multiply it back to get the original. This is actually something called completing the square in disguise right now. We'll probably talk about completing the square at a later time, but that's just sort of a little preview of where that's all going. Questions? All right. So this one says, given the area of the square, it says, find the side length. Okay, so we do our pattern again here. We look at this and we say, if you take the square root of 36, you'll get 6. If you take the square root of 10, you'll get 10. If you multiply 6 times 10, you'll get 60. And when you FOIL it back, that's going to happen twice. So we take the 60 times 2, and we get 120. So again, the middle guy is always the key. If we can get him to match up, we're good to go. So then the way you'd write this is you take the square root of 6, or excuse me, square root of 36 is 6. Square root of x squared is x. And then the square root of 100 is 10. And you're going to basically square it. So if you multiply this guy back out, you will get this stuff here. So if you had 6x plus 10 times 6x plus 10. So we do this, we get 36 x squared. We get 6 times 10, that's plus 60x. Looks real familiar, right? Do this, you get another plus 60x. And then finally you get 10 times 10, that's going to be 100. Add these two guys together, you get the 120 right there, so you're good to go. So this is your answer. Okay, so now that we know that, the only other thing here on this one, since this is a minus, we're going to have two minuses, so it's going to be a minus something squared. So again, we just look at this guy and we say the square root of 144 is 12. Square root of x squared is x. Since the middle guy is minus, we make him minus, and this has to be 1 times 1. So that's our guy. So as you can see, once you establish the pattern, this is pretty easy. Okay. So same thing here. we've got one of each. So again, the square root, look at this, you say, okay, square root of 64 is 8. And if I take 8 and multiply it by 2, I get 16. So this is a perfect square. So again, you set up shop. Say, I know it's going to be a perfect square. I take the square root of x squared, I just get x. I take the square root of 64, I get 8. This guy's positive, so make that positive, and we're done. Just like that. So the next guy here, it's like, okay, well, we have no middle term, right? So this is going to be the setup where we're going to have two things that pretty much look the same, except one's going to be plus and one's going to be minus. Okay, so we take the square root of x squared, we get x times x. Square root of 25 is 5 times 5, so it's going to be x plus 5 and x minus 5. And I think I may have inadvertently done this as one of our earlier examples, but that's okay. All right. All right, well, I really enjoyed talking to myself, but I think I'm going to stop here, and we'll do it all again tomorrow.